Okay, here we are. We're going to go over Q1 through Q10, and then numbers 1 and 2. So let's take a look at what we're asked to do here. Sorry about the drawing, it just doesn't seem to be working well right now, but it asks us to differentiate this function right here, and differentiate just means take the derivative. So it's y prime equals, I need to do 0.2 times 1215, which is 2430, but a decimal point adds a decimal point on there, so 243x to the 1214. Number 2 says find f prime of x if f of x is equal to x ln of x. That's an equal sign. You'll live. And I know what we'd like all to do is just take the derivative of each thing separately, put them together. We can't. This is a product rule. U equals x, u prime equals 1, v equals ln of x, ln, line. The derivative of ln of x is 1 over x, so it becomes u prime v minus uv prime, which becomes ln of x. Ooh, who said minus? I thought I heard that, but I changed it to plus really quick. Plus uv prime, which is x times 1 over x, which is equal to ln of x. Ln of x minus, let's see if this could cancel, 1. So that would be the correct answer there. Q3 gives us the following. Find y prime when y equals sine e to the 5x. I see the chain rule going on here. I see a function all the way on the inside here. I see a second function here. I see a third function here. So I'll start by taking the derivative of the outside. Derivative of sine of is cosine of, keep that same function, times the derivative of e to the is e to the times the derivative of 5x is 5. That answer is correct. You could write the 5 in front if you really wanted to. Okay, our next function says find the second derivative of y equals x to the 8th over x to the 5th. Darn it, I could use the quotient rule, and I could use the quotient rule again because it's a quotient, unless something simplifies to begin with. Oh, y is equal to, gang war, x to the 3rd. So I've already simplified it down. So the first derivative, y prime, is 3x squared. And the second derivative, y double prime, is equal to 6x. It would have been a lot of work to do it this way. You can always look to see if it simplifies first. Q6 says differentiate y equals sine of 8 over cosine of 3. There's no variables in there. So what does that make that, Tom? Tom Fay, look up. What does that make that? That's right, Tom. That makes that a constant. And the derivative of any constant, the rate of change of a constant, all the same words, is 0. B. Coco, what's wrong? Coco, no, Coco. Oh, Coco's crying because he's taking a derivative of a cofunction, so he knows the answer will be negative 1 over, cosine is similar to sine, square root of 1 minus x squared. That's a derivative of cosine. So the next piece, they're giving me some information. They say v prime at 5 equals negative 3. So what can I conclude about v of t at t equals 5? Well, I don't know where that graph is. I know when t is 5, there's some value to the function v of t. I'm going to pick any random point, doesn't matter. Put it on down there. But what I do know is I know the slope at 5. The slope at 5 is negative 3. Therefore, if I draw a line here, I know the graph has to be doing what? No matter what it's doing over here, I know at 5 it has to be decreasing, because the slope tells me so. Okay, the next function asks me for a derivative graph. It gives me a function y, and it asks me to graph y prime. This is y. So it's asked me to graph y prime. So the first thing I'm going to do, y prime is going to be the slopes of all of those points on the graph. This graph is continuous between pi over 2 and negative pi over 2, so we're going to work in those intervals. First thing we're going to look at is the slope ever negative. It appears the slope is never negative. Is the slope ever 0? I don't think the slope is ever 0. It doesn't look like it ever is 0. It looks like it's positive and gets less slopey, and then positive and gets more slopey. So positive and less slopey, positive and more slopey. So at first these slopes are they're positive, but they're getting smaller and smaller. Then it looks like they get to about 1, terrible lines I know, and then it looks like they increase. So I think around here the slope is 1. So I'm going to put a dot at what I'm going to call 1. And before that, the slopes are going to be decreasing. And after that, the slopes are going to be increasing. I think it's going to look something like that, which would make sense. The original function almost looks like a cubic function, so the derivative almost looks like a quadratic function. Next function says if u prime of 7 is 4, meaning the slope at 7 is 4, what can we conclude about u of x at x equals 8? Well, the information they're giving us tells us about 7. It just tells us the slope there is positive at 7. Guess what that tells me about 8? It tells me absolutely nothing, because this graph could go to here, have a point, and disappear halfway through, which would make it not continuous. Or maybe it doesn't. We don't know. This tells us nothing. We know nothing. None of A, B, and C are things we know about. Okay, we're asked to find dy dx and d squared y over dx. You can't find them without first finding dx dt and dy dt. And those are straightforward derivatives. dx dt is 4t to the third. dy dt, derivative sine of something, is cosine of something, times the derivative of the inside. Derivative of 3t is 3. You can write the 3 before or after. It doesn't matter to me either way. So dy dx equals dy dt over dx over dt. So make sure you put it in the right order. So it equals 3 cosine 3t over 4t to the third.